All right, let's tackle another question. This time it is question 103. It is the first mixed circuit we are going to consider. So let's read the question. Question 103, calculate the voltage drop from each resistance. Now note, I drawn the circuit a bit in a smaller version because we will need to simplify the circuit at each point, all right? So the circuit given as a battery and 4 resistor. So the battery is 24 volt. All the resistance are given. So we got R1 is 7 ohm, R2 is 10 ohm, R3 is 6 ohm, R4 is 4 ohm. Note, it is a mixed circuit because it got parallel and series section together. So for instance, if we go into this first resistance, this first resistance is in series with the remaining of the circuit. Once we arrive here at the junction, this becomes a parallel section. R2 is in parallel with R3 and R4. R3 and R4 are in series, all right? Now what we're going to do is we are going to go step by step simplifying this circuit. The first step we're going to do, and it's we have to start with that one, we can simplify R3 and R4. They are in series. And the trick to know if they are in series or parallel is always by considering the direction of the charge. Once the charge leave that junction and going through R3 and R4, all the charge going through R3 are going also through R4, all right? So we take R3 and R4, we simply add them together. So we got, this one is still R1. I'm not gonna write, well actually, yeah, I'm gonna write it. R1 is equal to 7. This one is still R2, so R2 is equal to 10. This one is I'm gonna write R3, 4, it is equal to 10 ohm in this case. All right? Let's go over here. The next step we need to simplify is these two are in parallel. Now they are in parallel because this wire over here and this wire over here share the same voltage. They have the same voltage drop on the wire over here. All right? So that's another trick to make sure they are in parallel. Circuit in parallel all share the same voltage, or resistance in parallel all share the same voltage. All right, so we combine these two together. So I'm gonna just write it 2, 3, R2, 3, 4, and it's equal to 5 ohm. Now, by the way, a hint, when you're dealing with resistance in parallel, the equivalent resistance is always lower than the lowest resistance. Here, well, the lowest resistance is 10 ohm. Now note, if you have two resistance with the same resistance, you will simply divide by 2. If you make sure you use the complete formula though, just to not make a mistake. All right, so we got 5 ohm over here. Again, this one is R1. It is equal to 7 ohm. Well, now we have a series circuit. We can simply add them up, and now we got our equivalent resistance. It is equal to 10 ohm in this case. And the power of the battery, 12 ohm, sorry. And the power for battery did not change, it is 24 volt. Now, I'm not gonna draw an ohm law table just because I don't have enough space. So we're going to work our way from the equivalent circuit up to the normal circuit, and we're going to determine the voltage at each point. So in this case, on the equivalent resistance, we have 24 volt. That means the total current has to equal 2 amp. 2 amp multiplied by 12 ohm is equal to 24 volt. Okay, look, so let's just make sure here. We got a current here. So the current going here and the current going here has to be the same. From the point of view of the charge, there's 2 amp going through the charge. So if we have a series circuit with the power source here, there's 2 amp going through the power source here, which means there's 2 amp going to R1 and 2 amp going through the remaining of the circuit. Now, even though we don't know how the current will be split here, all right? Not yet. We can right away find the voltage drop between these 2 points. If there's 2 amp over here, that means there's a voltage drop of 2 multiplied by 7. This one is 14 volt. What what that means is, well, there's 24 volt, 14 drop here, we got 10 volt here, and we can even confirm 2 multiplied by 5, we get a 10 volt drop over here. Now, let's see what that means. Let's say we choose before the battery, this is our 0 volt over here. 0, or our ground, if we prefer. Over here, we got 24 volt. And we just found that after the first resistance, there's a drop of 14 volt. This one consumes 14 volt. Well, if you have 24 volt and you lose 14, you're left with 10 volt. So you got 10 volt over here. Well, this remaining of this section over here is in parallel, which means the voltage apply on both, and we can find the current using that version over here. All right? Now, we are going to rewrite all the voltage here that we just found, and I'm gonna create an Ohm's law table just to make sure we correctly do all the calculation. All right? So this section over here, 0 volt, this section over here, 24 volt, this section over here, 10 volt, and that's it. We don't really need to know, by the way, yet the voltage here. We will need to figure it out before we are able to solve all the value, but you will see this one is quite simple. All right, I'm gonna erase the bottom part. If you need to pause the video, now's the time. And I'm gonna rewrite my Ohm's law table. Okay, so we got 4 resistor plus the equivalent resistor. So we got R, I, V, R1, R2, R3, R4, REQ. Okay, first resistance, actually, let's draw some line over here just to make sure we don't confuse any of the value with the other one. Okay, so R1, 7 ohm, R2, 10 ohm, R3, 6 ohm, R4, 4 ohm. We calculated the equivalent resistance to be 12. We know the total voltage to be 24. We calculated the current in the equivalent resistance. It is 2 ampere. All right. Now, one thing to note, from the point of view, there's 2 ampere going through the charge. This one is in series. R1 is in series with the power source, which means there is 2 amp over here. Now, by the way, once you got the equivalent resistance, you can already do that logic, okay? But sometimes it's easier to analyze when you're going from the simplest circuit and moving your way up. You just need to correctly identify each wire, which one they represent, all right? R2, in this case, R2 is this one. Well, we don't know the current going through R2, but we know the voltage drop now. It is 10 minus 0, so we got 10 volt on R2. Now note, because we know there's 10 volt, we know there has to be 1 amp, and right away we can know what is the current going through the other branch. There's 2 amp going here. One is going down. There's 1 remaining. It has to go in that direction. So we already know the current going through R3, and the same current going through R3 is also going through R4. So we got 1 amp over here, and we can solve the remaining of the table over here. All right. Now note, if we look over here, they don't add up to 24 because some sections are in parallel, some sections are in series, and these don't add up to 2. But if you look, let's say if you look at the loop, we got 24 volt here, we got a voltage drop across R1 and a voltage drop across R2. The voltage drop across R1 plus the voltage drop across R2 need to equal 24. 14 plus 10 equal 24. That's perfect. Same logic on the other loop. If you are voltage drop on R1 plus voltage drop on R3 and R4 has to equal 24. 14 plus 6 plus 4 is equal to 24. All right, so that's another way to solve this problem. Obviously, the Ohm's table, I find it always useful. Often you will, it will vary, it will highlight the next step. It's useful in that regard. All right. So that's it for question 103, where we're going to be solving one more example with mixed circuit, and then we are switching to Kirchhoff law. These problem will be a little bit more challenging. All right, so see you in the next video.